Okay, so we're back here for part 2. Now, we're going to continue here with number 5. Here's the one thing you've got to be careful about. Before you do ABC to set up your formula, we need the equation to be equal to 0, which means I have to move the 7. So I'm going to subtract 7 to start this, and we get x squared plus 6x minus 7 equals 0. Now I can say that A is 1, B is 6, C is negative 7. So we have x equals opposite B plus or minus square root B squared minus 4 times A times C, which is negative, all over 2A. All right, there's the setup. So we get x equals, that's just negative 6, plus minus the square root, 36 minus 4 times 1 times negative 7 becomes plus 28 all over 2. Now this is kind of nice because 36 plus 28 is 64. That's a perfect square, so we can simplify that. The square root of 64 is 8. So the square root, the radical, goes away. Notice that in this problem, it was not a perfect square, so our answer had square roots in it. But if we get a perfect square under that square root symbol, no more radicals, no more square roots. Okay, so now we'll break it into our two choices, two possibilities. Negative 6 plus 8 divided by 2. Negative 6 minus 8 divided by 2. That's plus or minus. Now notice I don't change the negative 6. That doesn't change. It's only the number after plus minus. This would add up to 2 divided by 2, which is 1. And this would subtract to negative 14 divided by 2, which is negative 7. And there's our solution set right there. And again, if I wanted to check, I can show you. We'd go back to the original problem here. So we would take x squared, x is negative 1, plus 6 times x, which is negative 1. If we are right, the outcome should be 7. Uh-oh. Oh, it should be positive 1. Excuse me, I put the wrong numbers in. So we should be doing 1 squared plus 6 times 1. Okay, so there's 7, so that's a check. Now, I didn't mean to make that mistake, but actually I'm glad I did, because as soon as I got a number that was different from 7, from the right side, I knew something was wrong. Either I mistyped or I solved it wrong. In this case, I mistyped it. Now it's okay. And then if I try negative 7, we would do negative 7 squared plus 6 times negative 7. Does it give us the right-hand value? Check. Okay, so those are the two solutions. So these three examples, these are good examples because there's really three situations that happen, three types of answers that you can get. And they're all based on what's happening underneath your square roots. If you end up with a perfect square like 64, the square roots will disappear and we're going to end up with two rational solutions, okay, that are fractions or in this case even integers. If you end up with 0 underneath the square root, then the plus or minus basically disappears and you end up with one solution that is a rational number. But if the number under the square root is not perfect, like 8, then what happens is you end up with two solutions, but they're both radical solutions. Negative 2 plus root 2, negative 2 minus square root 2, those are called irrational solutions. So those are the three ways that this can go. So if you flip this on the back, what we have is a word here, it's called the discriminant. And the discriminant is b squared minus 4ac, which, when we look at the formula, the quadratic formula, that is the expression that is underneath the square root. And what that tells you is something called the nature of the solutions. Roots is another word for solutions. If the discriminant is greater than 0 and it's a perfect square, such as 64, what we say is we get two, we'll say real, rational roots. Your answers will be fractions or integers. If b squared minus 4ac is greater than 0, if it's positive but it's not a perfect square, such as 8, we get two real numbers, but they are irrational. That's a number that as a decimal it keeps going. There's no pattern to it, no repetition, and it doesn't stop. If b squared minus 4ac equals 0, then what happens is we get one real rational root. Now, the last one here, if it's less than 0, this is something you would see in Algebra 2. This is not really an Algebra 1 topic, but if the discriminant is negative, if you had the square root of negative 4, for example, what you get is 2, and we call these imaginary roots. You don't have to worry about that. And that may seem a very confusing concept. How can answers be imaginary? But that's something that you'll learn at another time. Okay, so last thing we'll do here, directions. Determine the nature of the solutions using the discriminant and solve each quadratic equation. All right, so let's start with A, B, C. Now, instead of going straight to the solution, let's go ahead and do the discriminant first. Discriminant is b squared minus 4ac. So that would be 3 squared minus 4 times 1 times negative 5. If we work that out, that's 9 plus 20. So what we get here is 29. Oh, wait. Let's see. B squared minus 4a is 2. Excuse me. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is positive 40. 9 plus 40, is 49. Now, 49 is a perfect square. That's this situation right here. So we are expecting two real rational solutions, or roots. So now we'll solve it. Determine the nature of the roots. Two real, I'll use the symbol, rational. Okay. Now, for the equation, x equals opposite b plus or minus square root b squared minus 4ac. Now, we already know that. I don't need to rewrite it because it's the discriminant. So I can just put 49 all over 2a, and the a is 2. Okay, so what we get, x equals the opposite of 3 plus minus. That is 7. Square root of 49 is perfect. That's 7 divided by 4. And so now we do negative 3 plus 7 over 4. We do negative 3 minus 7 over 4. This is 4 divided by 4, which is 1. This is negative 10 divided by 4, which is negative 2.5. Okay, I'll write the decimal in this case. Or you could say negative 5 over 2. The decimal is fine. The fraction is fine. It's up to you. Those are the two solutions. Those are both rational. A decimal is a rational number. Okay, number 7. Now this is not in a good form. It has to be equal to 0 first. So let's move. I like to keep the x squared term positive. So I'm going to move negative 20x by adding it and negative 25 by adding it. So we have 4x squared plus 20x plus 25 equals 0. Those, we can't combine those. They're not like terms. So now we have a, b, c. All right, on the side, the discriminant is b squared. In this case, I don't really need the parentheses because it's a positive number. I'll put them anyway. B squared minus 4 times A times C. That's 400. Negative 4 times 25. You multiply them all at the same time. That's minus 400. Oh, that's 0. So the discriminant is 0. And when that's the case, you get one real rational root. So we should only get one solution here. Well, let's set up the equation now, the quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac, which is 0, all over 2a. Now, the square root of 0 is 0. If you add 0 or subtract 0, nothing changes, so you can ignore that. We get x equals negative 20 divided by 8, which reduces to, we can divide by 4, negative 5 over 2, or negative 2.5. And that's a good answer. All right, last one. Number 8. Now again, this is not set up well. We have to make the equation equal to 0. Let's move the 10x over by subtracting. And the other thing I'm going to do, I put my x term in the middle. So when I write this, I write the squared term, the quadratic, then I write the middle term, and then that's the linear term, just x to the first. Then I write the constant, because that helps me determine a, b, c. So let's go with the discriminant to start. D equals b squared minus 4 times a times c. Now that would be 100. Square a negative, get a positive. Minus 4 times 3 is minus 12. Minus 12 times 6, minus 72. And that is 28. Well, let's see. 28 is not perfect here, not a perfect square. That means we have two real irrational roots. So the nature of the roots will have two real irrational solutions. And I didn't write it in the last one, but I should have put here, this is one real rational solution. Okay, so the equation, x equals opposite b. Be careful, it's the opposite of negative 10, plus or minus square root. Now the discriminant is 28, so I can put that there. B squared minus 4ac, all over 2, and the a value is 3. Okay, so we get x equals, this is 10, plus minus, well, 28 is not perfect. Let's do a factor tree. 4 times 7, 7's prime, 2 times 2. Now we're looking to pull out pairs of identical numbers. Got a pair of 2's, that's 4. Square root of 4 is 2. And that's 2 square root 7, all divided by 6. All right, now look at the outside numbers, not the square root 7. 10, 2, 6. Can we divide by anything? We can. Each of those is divisible by 2. So we're going to reduce. What we're doing is reducing. And now that gives us, we have to divide each piece here. We get 5 plus or minus 1 square root 7, or square root 7, over 3. Now you can write it two ways. You can write 5 plus square root 7 over 3. 5 minus square root 7 over 3. But being mathematicians, we like to write things the simplest way possible. This is a case where you can write plus minus. You can keep the plus minus, write it like this. That means two solutions, here and here. But that's the easy way to write it. Now you may say, well, why don't we do that for number 6? Why didn't we do that here? Why did we actually have to break this up? And the answer is because we can actually combine these. We can do negative 3 plus 7. We can do negative 3 minus 7. So we can keep simplifying here. So that's why we keep going. But when you get to a number plus a radical, you can't combine that. We're not allowed to add that or subtract that because they're not like terms. So this is the easy way to do it. And that is the end of the notes.